Well, enough about that. Once we've talked about why straight lines are important, the next thing is, how do we measure straight lines? See, another interesting point is something like this. Many times we know what something means subjectively, but we don't know what it means objectively. For example, one way of finding a line is to know 2 points on the line. Another way is to know 1 point and the slant of the line. The question that comes up is, how do you measure the slant of a line? In other words, shall you say that the line is very slanty? And if the answer to that is yes, how do you distinguish between slanty and very slanty, steep and very steep and very, very steep? We need something more objective. And the way we get around this is as follows. Given a line, we define the slope as follows. We pick any 2 points on the line. And from those 2 points, we can measure what we call the run of the line. In other words, how far you've gone this way, and the rise of the line, how much it's risen this way. And what we do is we define the slope to be the rise divided by the run. Or, without the delta notation in here, y2 minus y1 over x2 minus x1. By the way, there are little problems that come up. After all, our answer should not depend on the picture. It should be sort of self-contained analytically. The question that comes up is, what if I had labeled this point x2, y2, and this point x1, y1? What would have happened then? And observe that as long as we keep the pairs straight, it makes no difference whether you write this or whether you write this, because you see in each case all you've done is change the sign, and negative over negative is positive. So certainly our answer to what a slope is objective enough so it does not depend on how the points are labeled. A second objection that most people have is they say something like, well, who are you to say that we picked these 2 points? What if I came along and picked these 2 points, and I now computed the slope by taking this as my delta y and this as my delta x? Obviously, it would be a tragedy if the answer to the problem depended on which pair of points you picked, since a line should have but 1 slope. Again, notice that our high school training in geometry, similar triangles, motivates why we pick ratios. Namely, while this delta y and this delta y may be different, and this delta x and this delta x may be different, what is true is that the ratio of this delta y to this delta x is the same as the ratio of this delta y to this delta x. And that's why we pick the ratio. By the way, another way of talking about ratio is if you look at delta y divided by delta x, and you've had some trigonometry, it reminds you of a trigonometric relationship. Namely, you look at delta y, you look at delta x, and you say, my, isn't that just the tangent of this particular angle? Couldn't I define the slope? And by the way, the general symbol for slope, for better or for worse, just happens to be the letter m. Why couldn't I define m to be the tangent of phi? And where phi is the angle that the straight line makes with the positive x-axis. And of course, there is a little subtlety here that we should pay attention to. This would be an ambiguous definition if the scale on the x and the y-axis were not the same. In other words, notice that by changing the scale here, I can distort the same analytic information. So if I agree, however, that the unit on the x-axis is the same as the unit on the y-axis, then I can say, okay, the slope is also tangent of the angle phi. I much prefer to say it's delta y divided by delta x, because then if I forget the scale, I'm still in no trouble.